King Louis XIV of France famously had the phrase Ultima Ratio Regum inscribed on his cannons. This Latin phrase translates to the last argument of kings. It served as a powerful reminder that when diplomacy and negotiations fail, the raw power of artillery becomes the final arbiter in conflicts between nations. Cannons were not just weapons, they were the ultimate expression of a state's will and strength. In an era of sail and musket, the thunderous roar of artillery could decide the fate of battles, break the walls of fortresses, and ultimately determine the victors of wars. This historical truth has not faded with time. The importance of artillery has been proven again and again throughout military history. From the Napoleonic Wars to the great conflicts of the 20th century, artillery has been called the king of battle. Its ability to deliver overwhelming firepower from a distance makes it indispensable. Artillery can suppress enemy defenses, destroy critical infrastructure, and inflict heavy casualties long before infantry troops engage in close combat. The psychological impact of a sustained artillery barrage is immense, capable of shattering the morale of even the most disciplined soldiers. In modern warfare, its role remains central to achieving tactical and strategic objectives on the battlefield. The ongoing conflict between Russia and Ukraine has powerfully reaffirmed this age-old lesson. Since the full-scale invasion began in February 2022, artillery has been the dominant weapon system, responsible for an estimated 70% of all casualties on both sides. The war has evolved into a grinding duel of firepower, where success is often measured by the number of shells fired and the accuracy of their delivery. Both nations have committed vast artillery resources to the fight, highlighting that even in the 21st century, with its advanced technologies, the brutal logic of massed firepower remains a decisive factor in large-scale conventional warfare. This conflict serves as a critical case study for military planners worldwide, especially for a nation like India, which faces complex security challenges along its borders. The lessons emerging from the plains of Ukraine are not theoretical. They are written in the stark reality of combat. They offer vital insights into the employment of modern artillery, the challenges of logistics, the impact of new technologies like drones, and the critical need for a robust industrial base to sustain a high-intensity conflict. For India, understanding these lessons is not just an academic exercise, but a strategic necessity for ensuring its future battlefield readiness. The sheer scale of artillery employment in the Russia-Ukraine conflict is staggering, underscoring its central role. Before the full-scale invasion in 2022, the conflict in the Donbas region saw daily artillery exchanges, but at a much lower intensity. Following February 2022, the use of artillery exploded. At the outset, Russia possessed a massive advantage with approximately 10,000 artillery pieces compared to Ukraine's 4,000. Even with significant Western support that boosted Ukraine's inventory to around 6,000 systems, Russia has maintained a numerical superiority in guns. This disparity in hardware has defined many of the tactical engagements throughout the war. The intensity of the fighting is best understood through the volume of ammunition expended. In the early phases of the full-scale war, daily artillery fire reached an average of 25,000 rounds combined. Even as the conflict has settled into a more attritional phase, the numbers remain high. Recent intelligence from late 2024 suggests that Russian forces continue to fire an average of 10,000 shells per day. This relentless rate of fire is used not just to destroy targets but also to suppress Ukrainian forces, disrupt their movements, and impose constant psychological pressure. The battlefield is a landscape saturated with explosive ordnance, a testament to the industrial nature of this war. This high rate of fire has come at a tremendous financial cost for both sides. A standard 155mm artillery shell can cost anywhere from $1,000 to $3,000, while more advanced precision-guided munitions like the Excalibur or Krasnopol are significantly more expensive. As of mid-2024, it is estimated that Russia has spent over $21 billion on artillery munitions alone, with Ukraine spending over $4 billion. These figures do not even include the associated costs of propellant charges, primers, transportation, and storage. The economic strain of sustaining such a high-intensity artillery war is immense and highlights the importance of a nation's economic resilience. The constant use of artillery has also led to severe wear and tear on the equipment. An artillery gun barrel has a finite service life, measured in effective full charges. Mathematical models suggest that the average Russian gun has already expended a significant portion of its service life. pushing it into the third quarter of its operational limit. This creates a massive maintenance and logistical challenge. Barrels must be replaced, and a large industrial capacity is needed to produce spares and conduct repairs. The conflict demonstrates that having a large number of guns is not enough. A nation must also have the industrial and logistical capacity to keep them firing. Russia entered the conflict with a well-defined artillery doctrine, refined through its experiences in Syria and Chechnya. This doctrine revolves around the concept of massed firepower, organized within a combined arms framework. A typical Russian division-sized formation includes a dedicated brigade artillery group, which can be equipped with multiple battalions of self-propelled guns, towed howitzers, and multiple launch rocket systems. This structure allows a commander to concentrate overwhelming firepower on a specific point in the enemy's line. Russian artillery is often positioned 12 to 15 kilometers behind the front line, moving forward to conduct fire missions before quickly withdrawing to concealed positions. A key element of Russian tactics is the shock fire or reconnaissance fire contour approach. This method is designed to be highly responsive and lethal, integrating various battlefield assets to shorten the sensor-to-shooter cycle. The process begins with unmanned aerial vehicles, such as the Orlan-10, and counter-battery radars identifying a potential Ukrainian target. The Russian forces may then use a small amount of fire to bait the Ukrainian artillery into revealing its position by firing back. Once the Ukrainian guns are located, their coordinates are instantly relayed to a waiting artillery group, which unleashes a rapid and intense barrage to destroy the target. This process has been made incredibly efficient through advanced command and control systems. Russia has increasingly relied on its Strelets battlefield management system, a digital network that connects sensors, command posts, and shooters. The Strelets system provides real-time data sharing, improved situational awareness, and secure communications across the battlefield. This digital integration allows for a targeting cycle that can be as short as 3 minutes from the moment a target is identified to the first shell's landing. This speed gives Ukrainian forces very little time to react or relocate, making them highly vulnerable to counter-battery fire. Despite the effectiveness of this doctrine, it is heavily reliant on a quantitative advantage in both guns and ammunition. The Russian approach prioritizes volume of fire over pinpoint accuracy for many missions. While they do use precision-guided munitions like the laser-guided Krasnopol, the conflict has shown that the bulk of the damage is inflicted by massive volleys of unguided shells. This tactic is effective for attrition and suppression, but it requires a vast and continuous supply of ammunition. The success of Russia's shock fire tactic is therefore directly tied to the performance of its defense industrial base and its ability to sustain the flow of shells to the front. Facing a numerically superior adversary, Ukraine has been forced to adopt a different approach to artillery warfare. Unable to match Russia's sheer volume of fire, Ukrainian forces have prioritized precision, efficiency, and tactical ingenuity. Their strategy has focused on a quality over quantity mindset, leveraging Western-supplied artillery systems that offer greater accuracy and range. Systems like the American M777 howitzer and the French Caesar self-propelled gun have allowed Ukraine to conduct effective counter-battery fire from safer distances. The goal is not to win a shell-for-shell exchange, but to make every round count by striking high-value Russian targets. A critical component of Ukraine's success has been its ability to integrate Western technology with homegrown innovations. Ukrainian forces have become masters of using small, commercially available drones for battlefield reconnaissance and artillery spotting. This agile and decentralized approach to intelligence gathering allows them to quickly identify Russian artillery positions, command posts, and ammunition depots. This information is then rapidly fed into targeting applications, sometimes colloquially referred to as Uber for artillery, which connect spotters directly with the nearest available gun battery. This network-centric approach significantly shortens their own sensor-to-shooter loop. The use of precision-guided munitions has been a game-changer for Ukraine. GPS-guided shells like the 155mm Excalibur have enabled Ukrainian gunners to achieve first-round hits on Russian targets with remarkable accuracy. While these munitions are expensive and in limited supply, they have been used to great effect against critical assets. A single Excalibur round can neutralize a Russian howitzer or command vehicle, an outcome that might otherwise require dozens or even hundreds of unguided shells. This precision allows Ukraine to inflict disproportionate damage on the Russian military, helping to level the playing field against a larger force. Despite these successes, Ukraine's artillery operations are constantly constrained by ammunition availability. The country remains heavily dependent on the United States and European allies for the continuous supply of 155mm shells and other munitions. At times, this has led to severe shell hunger on the front lines, forcing Ukrainian units to ration their fire strictly. While the ratio of fire has improved from a dire 1-to-5 in early 2024 to around 1-to-3 by late 2024, Russia still maintains a significant advantage. Ukraine's ability to sustain its defensive operations and mount counter-offensives is therefore directly linked to the political will and industrial capacity of its international partners. The Russia-Ukraine conflict will be remembered as the war where drones became a truly dominant force on the battlefield, fundamentally changing the nature of artillery operations. The sky above the front lines is teeming with thousands of UAVs, ranging from sophisticated military-grade reconnaissance drones to small, inexpensive quadcopters. This has created a condition of unprecedented battlefield transparency. The old methods of camouflage, concealment, and deception have become far less effective. For artillery crews, the constant threat of being spotted by a drone means that there is almost nowhere to hide. This new reality has placed a premium on mobility and survivability. Traditional towed artillery, which takes longer to set up and move, has proven to be extremely vulnerable. Once a drone spots a towed gun battery, it is often only a matter of minutes before counter-battery fire or a loitering munition arrives. In response, both sides have increasingly favored self-propelled howitzers and truck-mounted gun systems like Ukraine's Bodana or France's Caesar. These systems can execute a shoot-and-scoot tactic. They can rapidly drive to a firing position, unleash a few rounds, and immediately relocate before the enemy has time to retaliate effectively. The most disruptive innovation has been the widespread use of first-person view, or FPV drones as precision strike weapons. These small, agile drones, originally designed for racing, are retrofitted with explosive warheads and flown directly into targets by skilled operators. They are cheap, costing only a few $100s each, yet they can destroy equipment worth millions, including tanks, armored vehicles, and artillery systems. Both Russia and Ukraine are now engaged in a massive production race, with plans to manufacture millions of these drones. They represent a new, low-cost form of precision-guided munition that has democratized aerial attack capabilities. The ubiquitous drone threat has forced armies to develop new countermeasures. Electronic warfare, or EW, has become crucial for survival, with units deploying jammers to disrupt the control signals and GPS navigation of enemy drones. However, this has led to a continuous technological arms race, as drone manufacturers develop new frequencies and anti-jamming capabilities. Physical protection measures, such as overhead nets and so-called cope cages on vehicles, offer some defense but are not foolproof. The lesson is clear. In modern warfare, artillery survivability is no longer just about armor. It is about mobility, electronic protection, and the ability to win the invisible battle in the electromagnetic spectrum. The conflict has starkly illustrated the immense logistical challenge of supplying a high-intensity artillery war. The rate of ammunition consumption has far outstripped pre-war production capacities in both Russia and the West. Ukraine, for instance, has an estimated requirement of over 350,000 artillery shells per month to sustain its operations effectively. However, for long periods, it has received only a fraction of that amount from its allies. This significant gap between demand and supply has directly impacted Ukraine's ability to defend its territory and has forced its commanders to make difficult choices about which targets to engage. Russia, while also facing challenges, entered the war with a significant advantage: massive stockpiles of Soviet-era ammunition and a defense industrial base that was already geared for large-scale production. By shifting its economy to a war footing, Russia has been able to ramp up its manufacturing output significantly. It is estimated that Russia can produce nearly 90,000 artillery rounds per month, a figure that currently surpasses the combined production of the United States and Europe. This industrial strength has allowed Russia to maintain its high rate of fire and sustain its attritional strategy over a prolonged period. The war has exposed the vulnerabilities of lean, just-in-time supply chains that have become common in Western defense industries. For decades, many NATO countries reduced their ammunition stockpiles and production lines, assuming that future conflicts would be short and decisive. The prolonged nature of the war in Ukraine has proven this assumption to be dangerously wrong. the struggle to increase shell production has been slow and difficult, hampered by shortages of raw materials, specialized machinery, and a skilled workforce. It has served as a wake-up call about the need for industrial resilience and surge capacity. One of the most dramatic illustrations of logistical vulnerability was the successful Ukrainian strike on a massive Russian ammunition depot near Toropets in September 2024. This single strike reportedly destroyed 30,000 tons of munitions, equivalent to approximately 750,000 artillery shells. This loss represented 2 to 3 months of supply for the entire Russian army at its current firing rate. The incident highlights the critical importance of dispersed and hardened storage facilities. Centralized logistics hubs, while efficient in peacetime, become high-value targets in wartime, and their destruction can have a strategic impact on a nation's ability to fight. The artillery war in Ukraine offers profound and urgent lessons for the Indian Army. India, like Russia and Ukraine, operates a large and diverse inventory of artillery systems. The conflict validates the Indian Army's long-held belief in the primacy of firepower, but it also highlights critical areas where modernization is urgently needed. The first major lesson is the vulnerability of static, towed artillery pieces in a drone-saturated environment. A significant portion of India's artillery arsenal consists of towed guns, which would be at high risk in a future conflict against a technologically advanced adversary. Survivability now depends on mobility. Therefore, the Indian Army must accelerate its transition towards more mobile artillery platforms. This includes self-propelled tracked howitzers like the K9 Vajra, wheeled gun systems, and truck-mounted guns. These shoot-and-scoot systems are essential for surviving in a battlefield where counter-battery fire can arrive within minutes of firing. The conflict also underscores the need for a layered and robust anti-drone capability to protect these valuable assets. This includes a combination of kinetic solutions like anti-aircraft guns, sophisticated electronic warfare systems for jamming, and even directed energy weapons in the future. Artillery units can no longer operate without their own protective umbrella against aerial threats. The second critical lesson revolves around ammunition. The staggering consumption rates in Ukraine serve as a stark warning about the importance of maintaining large stockpiles and, more importantly, a robust domestic production capacity. India cannot afford to be dependent on foreign suppliers in a prolonged conflict. There is a pressing need to enhance the production capacity of India's Ordnance Factory Board and private sector partners to ensure a self-reliant and sustainable supply of all types of munitions, from basic high-explosive shells to advanced PGMs. The logistical network for storing and transporting this ammunition must also be made more resilient and dispersed. Finally, the war demonstrates the transformative power of digital integration. Russia's Strelets system shows the advantage of a networked battlefield, where sensors, command posts, and shooters are seamlessly linked. India must continue to invest in and field its own indigenous systems, like the Artillery Combat Command and Control System, or ACCS. Enhancing this network to integrate information from a wide array of sensors, including satellites, UAVs, and ground-based radars, is paramount. A faster, more accurate, and more secure sensor-to-shooter link will be a key determinant of success in future wars, allowing for more precise and timely application of firepower. Based on the lessons from Ukraine, the Indian Army should adopt a multi-pronged approach to enhance its artillery capabilities. In the short term, the focus should be on immediate adaptation and analysis. The Army must conduct detailed studies of the Russia-Ukraine conflict to fully absorb the tactical, operational, and technological lessons. This should be followed by a comprehensive audit of current artillery deployments, tactics, and ammunition stockpiles to identify immediate vulnerabilities. A critical priority should be to equip existing artillery units with basic counter-drone measures, including jammers and physical camouflage nets, and to update training drills to emphasize rapid relocation after firing. In the medium term, over the next 3 to 5 years, the focus should shift to procurement and training. The Army must fast-track the acquisition of more mobile artillery systems. This includes procuring additional K9 Vajra units, inducting mounted gun systems, and upgrading older guns by mounting them on high-mobility vehicles. Concurrently, there should be a significant investment in a diverse fleet of UAVs for reconnaissance, targeting, and battle damage assessment at all levels, from the battalion to the corps. Training programs must be overhauled to simulate a highly contested electromagnetic environment and to practice decentralized operations, where units must function with degraded communications. The long-term vision, spanning the next decade, must focus on self-reliance and technological superiority. India must make a strategic commitment to building a world-class defense industrial ecosystem capable of designing, developing, and mass-producing advanced artillery systems and munitions. This includes investing in research and development for next-generation technologies like long-range precision munitions, ramjet-powered shells, and directed energy weapons for drone defense. Establishing secure and resilient supply chains for critical raw materials, especially for explosives and propellants, is a national security imperative that must be addressed to avoid future dependencies. Finally, all these efforts must be underpinned by a robust command and control network. The continued development and integration of systems like ACCCS are vital. The ultimate goal should be to create a fully networked grid that connects every sensor to every shooter in near real time, leveraging artificial intelligence for faster decision-making and target prioritization. This will enable the Indian artillery to fully exploit its assets, delivering precise and overwhelming firepower when and where it is needed. This comprehensive roadmap will ensure that the King of Battle remains a decisive arm for the Indian Army, ready to face the challenges of the 21st century battlefield. The war in Ukraine has brought the brutal realities of industrial-age warfare crashing into the 21st century. It has stripped away assumptions about short, clean conflicts and reminded the world that the raw, destructive power of artillery remains the ultima ratio regum, the final argument of kings. The conflict has provided a live-fire laboratory, demonstrating that victory on the modern battlefield is forged through a combination of massed firepower, technological sophistication, industrial endurance, and tactical adaptation. For nations like India, which exist in a complex and often volatile geopolitical neighborhood, ignoring these lessons would be a grave strategic error. The key takeaways are clear and unambiguous. Artillery's lethality is magnified by its integration with drones, which have rendered the battlefield transparent and made traditional concealment obsolete. Survivability now hinges on mobility and robust electronic warfare capabilities. The sheer volume of ammunition consumed highlights the critical need for large stockpiles and, more importantly, a resilient and self-sufficient defense industrial base. Precision munitions are valuable, but they cannot entirely replace the tactical necessity of massed, conventional shelling. Finally, all of these elements must be connected through a secure and rapid digital command and control network to be truly effective. For India, the path forward requires a deliberate and sustained effort. It involves not just acquiring new hardware, but also rethinking doctrine, overhauling training, and making strategic investments in indigenous manufacturing. The Indian Army must accelerate its transition to a more mobile and protected artillery force, capable of surviving and thriving in a contested environment. It must embrace the drone revolution, both as a tool for its own forces and as a threat to be countered. Above all, India must build the industrial capacity to sustain a high-intensity conflict on its own terms, free from the uncertainties of foreign supply chains. The phrase "King of Battle" is more than just a motto. It is a strategic principle. The conflict in Ukraine has powerfully demonstrated that the side that dominates the artillery duel often dictates the tempo and outcome of the land battle. By heeding the lessons learned in the fields and cities of Ukraine, India can ensure that its artillery arm remains a formidable and decisive force. This will guarantee that if the day ever comes when diplomacy fails, India's own last argument will be overwhelming, precise, and victorious, securing its sovereignty and national interests for the future.